Chapter 4.2, exercises 25 through, I think we're going to go through 40 on this set. And this section of the book has to do with trigonometric functions of acute angles. And we're going to go on to this first set. In exercises 25 through 28, evaluate using a calculator, give an exact answer. Well, I see a little bit of a problem right off the bat, and that is that to find an exact answer, you're not usually going to use a calculator to get that exact answer. You're going to get an irrational number. But first, let's go to our calculator, and the first thing we need to do is check to make sure that we are in degrees mode, and we're going to use degrees mode for this whole set of exercises, no matter whether or not we're using radians. And so we go to our settings, document settings 2, and we see under angle that we are set in degrees, so we're okay there. Okay, now we're to this section of the calculator and the exercises. We're trying to find the secant of 45 degrees. And so we're going to go enter that into our calculator. And a lot of calculators don't have a secant. And to find out if you don't have a secant is the reciprocal of cosine. So if you needed to, you could rewrite the secant of 45 degrees as 1 over cosine of 45 degrees. But fortunately, on our calculator, TI Inspire CX calculator, we do have a secant key. And so we go there by pressing the trig button, which is over here on the left side, just trig, and we go over to secant, and we know secant's related to cosine because it's like sine, cosine, tangent, cosecant, secant, cotangent. So secant goes with cosine. Secant is a reciprocal ratio of cosine, so we put in 45 degrees, and we get 1.41421. Okay, so $1.41421. Now, we were asked about an exact answer, and this is an irrational number, not an exact answer. So we're going to have to go to 45 degrees to get an exact answer. So it's saying use the calculator, but then it's effectively requiring us to use something else. And so if we draw a 45-degree right triangle, which is right here, and we have the sides x, x, and x square root of 2, our cosine theta equals our adjacent. In this case, our adjacent is x over our hypotenuse. So we put in x over x square root of 2, and we cancel, we get 1 over square root of 2. And what's happening is that secant, instead of being adjacent over hypotenuse, is hypotenuse over adjacent. So it's going to be the reciprocal of 1 over square root of 2, because, or we put hypotenuse over adjacent, we have our hypotenuse is x square root of 2, and our adjacent is x. So our answer is going to be square root of 2. And so the thing asks us to use a calculator, but you really have to break it down to the original schematic to figure out what it really is, unless you happen to know 1.41421 is a decimal approximation of square root of 2. Next on our problem, we have the cosecant of pi over 3. And when you see pi as part of an angle, what that means is pi over 3 radians. And we're going to convert pi over 3 radians into degrees. So for that conversion, we need to know that 180 degrees is equal to pi radians. And where we get that from is if we look at a circle here, if we rotate halfway around the circle, that's going to be 180 degrees, which is the same as pi radians. So pi radians. And if you remember this relationship, 180 degrees equals pi radians, you don't have to memorize a formula so much. So anyway, this pi radian, pi over 3 radians, okay, pi over 3 radians, we convert that to degrees by multiplying by 180 over pi radians. And pi radians over pi radians cancel, so we get 180 degrees, that's 180 degrees, over 3, which equals 60 degrees. And for that, 60 degrees, we're talking about this type of angle here. Okay, here's our 60 degrees, and we're trying to find the cosecant. Well, cosecant is related to sine, okay? And for this, we're going to have x as our short side, 2x is our hypotenuse, and our long side, this other opposite side, is going to be x square root of 3. And what's happening is that cosecant is a reciprocal of sine, so that's going to be hypotenuse over opposite. And this x squared root of 3 is our opposite side, and this 2x is our hypotenuse. Now we can put this in our calculator. It's going to be the same as cosecant of 60 degrees. Cosecant of 60 degrees. In our calculator, we go to our trig key again, and then we go over for the right to cosecant, and we'll put in 60 degrees, and we get 1.1547. Again, that's an irrational number. Should be pretty apparent. 1.1547. But to find out exactly what it is, we take the hypotenuse over opposite, and our hypotenuse is going to be 2x, and our opposite is going to be x square root of 3. So x over x are going to cancel each other. So cosecant theta is going to be 2 over square root of 3. And rationalizing, multiplying by square root of 3 over square root of 3, we're going to get 2 square root of 3 over 3. So that'll be our answer. Again, pretty puzzling because it says using a calculator, but the answer is given. Yeah, it's going to be equals 2 square root of 3 over 3. Next set, exercise 29 through 40, evaluate using a calculator. Be sure the calculator is in the correct mode. Well, we already did that prior to this video lesson. So the first one we have is sine of 74 degrees. Already understanding that we are in degree mode, we just go to sine of 74 degrees, and it says to 3 decimal places. So we get 0.961262. So 3 decimal places is going to be 0.961. So we'll say, instead of equals to, I'll say approximately equal to 0.961. The sine of 90 degrees would be exactly 1. So that's pretty close as we move up as the angle gets closer to 90 degrees. Next, the cosine of 90 degrees, 23 minutes. Okay, here we have, we need to have degrees mode, and that's going to be 19 plus, we got to change this 23 minutes into degrees. So we're going to have 23 sixtieths is going to be our amount in degrees. So we can just do this all at once if we want to. We want to have the cosine of 19 degrees, 23 minutes. So we go to our trig button, cosine. We'll have 19 degrees plus, I'm just going to put 23 over 60 here inside the parentheses with the 19, and we'll get our answer, which rounded to 3 decimal places is going to be 0.943. Okay, 0.943. Again, we had to convert our DMS, in this case our minutes, 23 minutes, into a degree by dividing that 23 minutes by 60. So we're going to get 19.3 something minutes and degrees. Next on our problem, which is 33, tangent of pi over 2. So we're going to convert this pi over 2 is quite obviously in radians. So we have pi over 12 radians. I said pi over 2, 12. And to convert to degrees, we multiply this by 180 degrees over pi radians. And we have cancellations here. Pi radians over pi radians cancel each other. So we get 180 degrees over 12, which is going to be equal to 15 degrees. Let me be sure here. 180 divided by 12, I'm pretty sure 15 degrees. Yeah, 15. So we're just going to go ahead and take the tangent of that 15 degrees. So I'm going to go ahead and place the trig button, tangent 15 degrees, and for that we get 0.268 rounded to the nearest 3 places. So 0.268. That's going to be our answer for problem number 33. Next on our problem 35, secant of 49 degrees. Well, here there aren't any conversions to be made, so we'll just go straight to our calculator. Secant 49 degrees, so we go to our trig button and go to secant, and we put in our 49 degrees, and we get 1.524 rounded to the nearest 3 decimal places. .524. Pretty straightforward. Next on our problem, 37, we have the cotangent of 0.89. Well, what does it say 0.89 what? What? 0.89 what? Well, we don't see a degree here. And owing to the number, we're going to make an assumption that we're talking about 0.89 radians. And we just don't have enough going. Sometimes you have real small numbers like this. It's going to be radians, and you don't see specifically a degree marked here, so we're going to assume radians. So we're going to convert this radian measure. We have 0.89 radians, and to convert to degrees, we multiply by 180 degrees over pi radians. Now, when we have the radian measure in something pi, we would cancel out pi radians. But in this case, we're just canceling out radians over radians. So our answer is going to be 0.89 times 180 degrees over pi. And we say our answer, and that's not really the case, right? Because we're going to use this answer here to plug in as degrees into our calculator. And so going to our calculator, we get 0.89 times 180 degrees, and we're going to divide this by pi. And again, we divide by pi because pi didn't cancel out like it has in our earlier uses of conversions to radians and degrees. So you get 50.9932 degrees. .9932 degrees. And so we're going to put our cotangent of that amount in here. And if we didn't have a cotangent button, we could use 1 over tangent. But let's go to our calculator. We're going to say cotangent. Oops, the last thing here. And I'm going to put ANS. ANS we find by pressing Control and then the negative sign. And so that gives us the last number calculated, which in this case is 50.9932. Press Enter. And you see, as the thing is worked out, it has more decimal places than 0.9932, so a more exact answer. But rounding in 3 decimal places, we're going to have 0.810. You see that? So 0.810, go here, 0.810. Okay, the last another problem we're looking at in this set is 39. And we have, for this one, the cotangent of pi over 8. So we're going to convert pi over 8, and that's going to be pi over 8 radians, into degrees by multiplying by 180 degrees over pi radians. And pi radians over pi radians cancel. So we end up with 180 degrees over 8, which is equal to 180 divided by 8. We get 45 over 2, and just to get a decimalized answer, we get 22.5 degrees. So 22.5 degrees. And so we're going to place this cotangent of 22.5 degrees. So trig button. And I'm going to use the last number calculated like we did in the last one. Control negative sign. So we get 2.414 rounded to the nearest thousandth or third decimal place. So these are the odd number problems being worked out. Good luck in working out the even numbered problems. as a demonstration of your learning. And thanks for viewing.